As engineers design complex mechanical systems into today's buildings, properly designed ventilation systems are critical in providing a comfortable environment and acceptable indoor air quality. Proper fan selection and duct design is important whether designing office buildings, schools, hospitals, warehouses, or commercial retail space. Now let's examine how duct design and installation can affect fan performance. Normally, a fan is tested with an open inlet and a section of straight duct attached to the outlet. This setup results in uniform airflow into the fan and efficient static pressure recovery on the fan outlet. To observe the movement of air molecules in the duct, we've introduced helium-filled bubbles into the airstream. When space constraints do not allow for a section of straight duct, an elbow must be placed near the fan outlet. But look what happens. This installation results in an abrupt change in direction of airflow. It causes turbulence within the fitting. One bad connection can reduce airflow significantly below the fan's catalog performance. To calculate airflow in the duct, we've installed an airflow measuring station. This duct configuration is a reproduction of a test setup from AMCA Standard 210. Unrestricted, this fan delivers just over 1,800 CFM. Now we'll add an elbow to the duct. Notice the turbulence within the fitting. It causes significant pressure drop. In this example, simply by adding one elbow to the system, airflow has been reduced approximately 25%. One way to improve the efficiency of air movement through the fitting is to install turning vanes in the elbow. The airflow is less turbulent and more uniform at the discharge of the fitting, resulting in a lower pressure drop. In this case, the airflow has only been reduced about 6% from the fan's initial performance. Many designers prefer utilizing radius elbows. In this test, this is the most efficient fitting of the three. The reduction in airflow is less than 4%. Remember, as originally tested with an open inlet, this fan delivered just over 1,800 CFM. In many cases, air is ducted to the inlet of the fan. For proper performance, air must enter the fan uniformly over the inlet area in an axial direction without pre-rotation. This results in an airflow reduction of less than 1%. Occasionally, space limitations do not allow the designer to provide a straight inlet to the fan. Many times, this type of fitting is attached to the fan inlet. With this type of duct connection, a counter-rotating vortex appears. In this case, airflow has been reduced approximately 45%. Non-uniform flow into the inlet is the most common cause of reduced fan performance. These conditions alter the aerodynamic characteristics of the fan so that its full airflow potential is not realized. Listen to the pulsating sound of the fan. Notice that the fan is hunting, trying to find a stable operating point. The loss in performance with this type of connection is obvious. This loss is often referred to as system effect. To make matters worse, it cannot be measured. To select and apply the fan properly, these effects must be considered, and the pressure requirements of the fan must be increased. Fortunately, there is a better way. A sweeping radius elbow at the inlet provides a more efficient solution. In this case, the airflow has been reduced around 3%. By inserting a straight section of duct, the airflow is now just 2% below the fan's catalog performance. In summary, proper fan selection and performance can be achieved if calculated duct losses as well as system effect factors are considered during the design stage. At Loren Cook Company, we are committed to meeting the customer's needs while leading the industry in quality. This begins with the application of the most sophisticated design tools available, including computational fluid dynamics, finite element analysis, and three-dimensional solid modeling. Fan performance is then verified in our AMCA-registered laboratory. Production quality is assured through a combination of the latest in CNC-controlled equipment and a highly skilled and dedicated workforce. Our commitment to quality is demonstrated by Loren Cook Company's ISO 9001 certification.